Okay, so now I have another question for you. Suppose I were to offer you two gambles, and you could choose which one, just like before. Gamble A is exactly the same as it was in the first example. I flip a coin. If it lands heads, you get $20 million. If it lands tails, you receive nothing. Under Gamble B, you get X million dollars with certainty. My question for you is, what value of X would leave you indifferent between these two gambles? That is, what value of X would make it so you don't care or have any preference about which of these two options that you get? So think about that for a moment. And you can pause the video if you want to think about it. So pause the video now. So you might have answered something like $7 million, or I've seen this in the past. Some people said 9, some people said as low as like $1 million, right? I mean, if you get $1 million, that would dramatically change your life. Maybe that makes you just as happy as having a 50-50 gamble between 20 million and 0. Okay. Whatever value of X that you answered, that is what we're going to call your certainty equivalent. Okay. The certainty equivalent is the amount that, if received with certainty, would make you just as happy as you are under the gamble. A related concept is risk premium. Right? So you were willing to take $7 million instead of that gamble, which paid you $10 million in expectation. You're giving up some expected income by taking the certainty equivalent. Okay? The risk premium is equal to how much you're willing to give up in expectation to get rid of the risk. So if your answer was $7 million, if that was your certainty equivalent for Gamble A, and remember Gamble A had an expected income of $10 million, your risk premium is the difference, or $3 million in that hypothetical scenario. So now we're going to go through an example to actually try and derive these values, the certainty equivalent and the risk premium. Okay, so in this problem, we're going to assume that the utility that's associated with a given level of income in, let's say, a year, is simply the log of the income. And the gamble is with half probability your income is 1, and with the remaining probability your income is 9. Let's say what the units are. I mean, 1 is, if it's in dollars, it's not very lot. Let's say it's bitcoins or something like that. Okay, so the first question is, what is your certainty equivalent? So another way to ask that is, for what value of X is the utility of X equal to the expected utility under the gamble? We're trying to solve for what amount, if received with certainty, would give you the same utility as the expected utility in the gamble. Okay. Plugging in the values for this particular problem, we have that u of X is equal to the probability of the first outcome, which is 0.5, times the utility of the income in the first outcome, which is 1, plus the probability of the second outcome, which is also a half, or 0.5, times the utility in that latter case, which is the utility of $9 in income, so u of 9. Okay, we could take that a step further, and we could plug in the utility function here. So we have u of X is equal to 1/2 times the log of 1 plus 1/2 times the log of 9. That is, we plugged in the utility of a certain level of income as simply the log of that income. Okay. Now for the next steps, what you need to remember, and what I'm going to encourage you to go back and look at, is your logarithm rules. So for example, if you had A multiplied by the log of B, that is the same thing as the log of B raised to the power of A. Okay, so if we use that simplification, we can rewrite this expression as follows. We have the utility of X is equal to log of 1 raised to the power of 1/2. And then we're going to do the same thing with the second part of this equation. 1/2 times log of 9 is going to be equal to the log of 9 raised to the power of 0.5. Now, one thing you might remember is square root of 1 is 1, and the log of 1 is 0. So this part just drops out. That's just equivalent to 0. And this part here, log of 9 raised to the power of 0.5, that's just simply equal to log of 3. Okay. And lastly, remember that the utility of some level of income, if received with certainty, is simply equal to the log of it. Okay, so remember, we're trying to solve for x. Next question is, what value of x makes it so that the log of x is equal to the log of 3? Well, x equals 3. So the certainty equivalent is x, which in this case is 3. So that suggests that the person would be just as happy taking $3 of income or whatever units, bitcoins or whatever, with certainty as they would be under the gamble that was posed before. Okay, so the next question that I have for you, now that we found the certainty equivalent, how do we find the risk premium? How do we find how much this person is willing to give up in expectation to get rid of the risk associated with the gamble? Now remember, the risk premium is equal to the expected income in the gamble minus the certainty equivalent, which we'll abbreviate CE. Okay. So to solve this problem, we already have the certainty equivalent, that's 3. But to solve it, we need to go back and find the expected income. So let's do that. Expected income is the probability of the first outcome times the income in that case, which is 1. Plus the probability of the second outcome, which in this simplified example is also 0.5, times the income in that case, which is 9. And if you solve it out, you could see it's simply equal to 5. So the expected income, if you were to take the gamble, is 5. You don't actually get $5. You either get 9 or 1, but the expected income is 5. To calculate the risk premium, we subtract from the expected income of 5 the certainty equivalent, which we found was 3. So the risk premium in this example is 2. So this says that the person is willing to give up to an income in order to avoid the risk that's associated with the gamble.